This is Ben McGahee with Yamie Chess. I'm going to be your math teacher today. Yamie Chess is the math learning aid based on classic chess that helps students in math and science education for school. In this lesson, we will learn about variables, constants, and algebraic expressions. So, what is a variable? A variable is like a letter or a symbol that represents some number. So, for example, we have D. The letter D represents distance. We could have the letter T, which represents the time. Or, like in geometry, we could have the Greek symbol, this is called theta, which represents an angle. And there are many other variables out there that you can use to represent something in the real world. And when you learn formulas in your classes, like for physics, chemistry, biology, engineering, or any of the science courses that you take, you will experience a lot of different kinds of variables in the formulas that represent certain things. Now, on the other hand, we have constants, and these are values that do not change. They always stay the same. So, for example, we have the number 7. That's considered a constant. The fraction negative 1/2 is also a constant. And we also have the irrational number pi, which is 3.14159, etc. This is also an important constant that you use when finding circumference, area, and volumes dealing with circles and spheres. And then the last thing we want to talk about is an algebraic expression. So an algebraic expression is a type of expression in algebra that involves both the variables and the constants. So for example, you may have an algebraic expression. This is read as 2x plus x squared. Another expression you might have that's an algebraic expression is 3 times the quantity 4 minus y, and then plus 8. You might also have algebraic expressions with more than one variable. You notice that there's a and z in this expression. You may have a minus 2 times the square root of a z over z plus the absolute value of a. So we can have algebraic expressions, with just one variable. There might not be any constants. You could have something like, x to the third. That could be considered an algebraic expression. Or you can have the algebraic expressions that have both, the variables and the constants together, like we see in these 3 examples. So as long as you have, some variables in your expression, it's considered an algebraic expression. So now what we're going to do is look at a couple examples on how to evaluate algebraic expressions. And so what does it mean to evaluate an algebraic expression? It just means to find a number based on a given values that you're going to plug into expression, and then use order of operations to evaluate the algebraic expression. So we're going to look at this first example. It says a quantity of x minus 5 cubed to the third power plus 10x And when we want to evaluate this algebraic expression for x equals 2. X equals 2. So this means that wherever we see an x, we're going to put the value of 2 in and then evaluate it. Okay, so we'll do our parentheses. And since we see an x here in this place, we're going to replace that with a 2. So we'll have 2 and then minus 5 to the third power, and then plus, and then we have 10, and then times x, so x is 2, so we'll put parentheses. Okay, so this is going to equal, so now we're going to do the order of operations tells us to do the parentheses first, right? So we're going to do 2 minus 5, and we get negative 3 to the third power plus, and then the next thing to do is multiply 10 times 2, and that's going to be 20. And then the next step here is to do negative 3 to the third power. So that's the same as negative 3 times negative 3 times negative 3. So we're going to have, if we multiply these together, put our parentheses, negative 3 times negative 3 is positive 9. And 9 times negative 3 is negative 27. So we'll have negative 27 plus 20. And so we're almost done here. So what we're going to do is we're going to add these together, negative 27 plus 20. So this is kind of like subtracting because the numbers are opposite signs. So it's like 27 minus 20 will give us 7. And then we take the sign of the bigger number. That's 27, so it's a negative. So that means our answer is going to be negative 7. So that is the value that we get when evaluating this algebraic expression for x equals 2. We get negative 7. Okay, let's look at the second example. We want to evaluate 2 plus r all over or divided by t squared minus the square root of r. T squared minus square root of r. And this is for r equals 16 and t equals negative 5. So now we have an algebraic expression with two variables. We have r and t that we're going to plug in to our expression. Okay, so let's do that. So we have 2, and then we have plus, so we have r. We know that that's going to be 16 all over t. Value of t is negative 5, and so we're going to square that, put it in parentheses, negative 5 squared, and then minus the square root of r, and so we know r is 16. Okay, so we plug both of our numbers in, the r equals 16 and t equals negative 5 into our expression. And so now we're going to evaluate the numerator. We're going to do 2 plus 16, and that gives us 18 over, and then we do negative 5, all of that square, so that's negative 5 times negative 5, And so negative times negative is positive, so we get 5 times 5 is 25. And then minus the square root of 16. So what number times itself is 16? That would be 4 times 4 is 16, so that would be 4. So the square root of 16 is 4. So we have 18 over 25 minus 4. And so that's going to give us 18 over, and then the next thing to do is subtract 25 minus 4, and we get 21. And then our last step here is we probably need to simplify, right? 18 over 21. And we know that there is a common factor of 18 and 21. It would be 3, right? So we would divide each number by 3 to simplify. So that equals 18 divided by 3 is 6. And 21 divided by 3 is 7. So our answer is 6 over 7, or 6/7. So in this example, you got some practice plugging in to two variables and worked on your dividing and square roots and simplifying fractions. So you got to practice a little bit of everything there. I do want to emphasize that if you are struggling, with order of operations, it is something to review, especially when you're doing algebra. You need to know your order of operations in order to evaluate algebraic expressions. So, I'll probably be doing a video, review in the future for algebraic, or for order of operations. So that way you can watch that to help you review and get a good hold on the algebra as far as evaluating algebraic expressions. Okay, so now we're going to do some problems you can try on your own. And here are the two problems. The first one says to evaluate the absolute value of negative a plus 8 times the quantity a minus 1/4 for a equals negative 1/2. So a equals negative 1/2. So be careful in your signs when you plug in. That's very important. And then for the second problem, you're going to evaluate the square root of v naught, that's how you pronounce that with the 0, v naught squared minus 2gy. And this is evaluated for v naught equals 30, g equals 10, and y equals 25. So this algebraic expression is based on an equation that you'll learn in physics when you're talking about projectile motion of objects that fly up in the air and fall on the ground, like a cannon or a missile, or even if you just throw a basketball up in the air, shooting hoops, and then it falls on the ground. So this is an expression to help you find, the final speed of that projectile. Okay. So I'm going to let you try those problems on your own. Feel free to pause the video and even rewind if you need to review how to evaluate algebraic expressions. Feel free to look at those examples we did earlier. So Okay, so let's go over the answers. For the first problem, we have the absolute value of negative a plus 8 times the quantity a minus 4 for a equals negative 1/2. So we're going to plug in this value, negative 1/2, in for a. So that'll be absolute value of negative, and then we'll put parentheses minus 1/2, and then plus 8 times negative 1/2 minus 4. So you're going to get a little bit of practice with your fractions here in this video. So that's going to give us, let's see, the opposite of negative 1/2 is positive 1/2. So we'll have absolute value of 1/2 plus 8 times, and so negative 1/2 minus 4. So in order to add, or I guess, or subtract these fractions, we need to get a common denominator. And we see that the least common denominator out of 2 and 4 would be 4, right? So what we can do is multiply. We know 2 times 2 is 4, so we'll multiply the top and bottom by 2 in this fraction, so we can get the common denominator. So that would be 2 times negative 1, that's negative 2. 2 times 2 is 4. So we have negative 2 over 4 minus 1 over 4. And so adding the numerators together, we get, what's that, negative 2 minus 1 is negative 3 all over 4. Okay, so we're going to get negative 3/4. So the next step is to take the absolute value of 1/2. So absolute value is the distance. The number is from 0. And so the absolute value of 1/2 is just 1/2. So remember that the absolute value of a number is just, just usually the positive number regardless of the sign. So if you have a negative number, it's going to be just the opposite sign. If you have a positive number, inside the absolute value, it's just going to be that number. And then, of course, the absolute value of 0 is 0. So then plus, we have 8 times negative 3/4. So we could divide, let's see, cross cancel 4 into 8. 4 divided by 4 is 1, and then 4 goes into 8 2 times. And then we have 2 times negative 3 is negative 6. So I have 1/2 plus negative 6. And so what we need to do is we need to get a common denominator. And for this would be 2 for the common denominator. So we would have, let's see, this would be 1/2. And then if we multiply the top and the bottom by 2, we're going to get negative 6 times 2 is negative 12 over 1 times 2 is 2. And then we just combine the numerators together, so we get 1 minus 12, that's negative 11 all over 2. So 1/2 minus 12 halves, it's negative 11 halves. And that would be our answer. And so we get this for our answer, negative 11 over 2. Okay, so for the next problem, we want to evaluate the square root of v naught squared minus 2gy for v naught equals 30, g equals 10, and y equals 25. So what we're going to do is go to the next board with the answers. Let's evaluate this expression and see how they got the answer here. So we have the v naught squared minus 2 gy, v naught is 30, g equals 10, and y equals 25. Okay, so we're just going to plug our values in here where the v naught, g, and y belong. So we're going to have 30 squared minus 2 times 10 is g times y is 25. Okay, and then that's going to give us, so 30 squared, that's 30 times 30. So a way to do that in your head is just to multiply 3 times 3 is 9, and then add 2 zeros because you see 2 zeros. So 900. And then minus. Then we can multiply these in any order. So it doesn't matter which ones you want to do. So we can just do left to right. So we have 2 times 10 is 20. And then 20 times 25. Let's see what that gives us. So we're going to do 25 times 2 first. And then we can add a 0 at the end to get 20 times 25. So we have 5 times 2 is 10. Carry the 1. 2 times 2 is 4. Plus 1 is 5. So that's 50. So 20 times 25 must be 500. Okay, so we have the square root of 900 minus 500. And so that's going to equal square root of 900 minus 500. Well, 900 minus 500 is 400, right? Okay, so the square root of 400, so what number times itself would give me 400? Well, I know that the square root of 4 is 2, because 2 times 2 is 4. So let's see here. 400's a lot bigger, right, than 4. So 100 times bigger. What if we try something like 20, let's see, times 20. Let's see, 2 times 2 is 4, and that little trick with the zeros, you have 2 zeros here, so that's going to give me 400. So I see that the square root of 400 is 20. And that's how they got 20 for the answer. So if you got both of those answers, the first one, -11 halves, or -11 over 2, and the second one is 20, well done. Great job. So this has been McGahee, and I want to thank you for watching this lesson on variables, constants, and algebraic expressions. Please stay tuned for more lessons on YamieChess.com. Have a great day.